We have a treat for you. The Commissioner mentioned him yesterday, described him as the father of open innovation. Our keynote speaker this afternoon is Dr. Eric von Hippel, who is T. Wilson Professor of Technological Innovation in the Massachusetts Institute of Technology, better known as MIT Sloan School of Management, a professor in MIT's Engineering Systems Division, and head of the MIT Innovation Lab. He is, ladies and gentlemen, a guru on this subject, so we can have no one better to talk to us about opening up Europe to citizen innovation. Before I bring him up, I should just say, after him, we are going to hear from Pedro Oliveira, Associate Professor at the Católica Lisbon School of Business and Economics, who's going to give us a very practical example of what Dr. von Hippel is talking about in practice. If there is time, we will take a couple of questions at the end, but we will see how we go. It is my pleasure and my honor to give you the floor, sir. A very warm welcome, and over to you.
Thank you. Hi, I'm very happy to be here. Thank you, Commissioner Modash and members of the EU Commission and colleagues and guests. What I'm going to talk about is something that is really something that over some decades now, 200 of us or so have developed. And I have two excellent colleagues right here, Pedro, who will talk to you afterwards, and Jeroen de Jong from the Netherlands, who also is a contributor to all this work. So let me begin and tell you first that what we are talking about is an enormous change in the way innovation is understood. And over this half hour, I will give half an hour of a talk, and then Pedro will take 10 minutes. What I'll talk about is citizen innovation that was not contemplated by Schumpeter and is not sort of part of economics now. In economics, citizens, the household sector, have been traditionally viewed as passive consumers of producer-developed products and services, not as developers themselves. So what Schumpeter said is, it is the producer who, as a rule, initiates economics change, and consumers are educated by him if necessary. He wasn't even quite sure that you had your own needs. And really, it was somehow the producer that innovated. The consequence of this for policy is enormous, because if we assume we have producer innovators, we have a market failure in terms of spillovers, which leads to the justification for the patent system with its known devil bargain qualities of raising prices and so forth, R&D subsidies and the rest of it. That process, as you know, is the linear innovation process typically called, where you have market research, you have R&D, production, and market diffusion. Now, all of these things are done for profit. It's a market-driven system. Now, here's the contrasting issue. It turns out, colleagues and I have done several studies now of national representative surveys of citizens and their innovation activities. This does not exist in governmental statistics. Governmental statistics on innovation focus only on producers. When we went, however, we looked, what we found was an enormous amount of citizen innovation. It was in the UK, which is the first column there, we found that 6.1% of the population developed or produced consumer products for themselves. 6.1% of the population is 2.9 million people in the UK. In aggregate, they spend $5 billion. In contrast, the entire industrial R&D mechanism, which policy is focused on, spends less in the UK. In fact, if you look in the UK at the number of people who are full-time R&D employees working to create products for consumers, that is about 22,300. In other words, what happens is consumer innovators outnumber producer innovators by more than 100 to 1. And yet they were entirely invisible because we don't think about R&D that way. So one of our challenges is to get the innovation that is invisible but major in the EU and elsewhere visible so that we can deal with it. Now, what we've done is we've defined two paradigms. The first one is the one that you saw. A good deal of innovation does go by producer innovation as I described it. Paid employees do market research, R&D, production, and then it is sold for profit. Now contrast this with the top row. The reason we have it as a citizen innovation paradigm, which is distinct from the producer innovation paradigm, is it operates by different principles. Basically, citizen developers are self-rewarded. No, nobody's paying them. When you go and you develop a product for yourself, nobody's paying you. And I'll give you some examples. Others then collaboratively innovate and improve because in general, you do not protect your innovation information. Right? You give it away. The result is, again, peer-to-peer free diffusion occurs at the end of the citizen innovation paradigm. A very different kind of a matter. Now, I'm going to give you some examples of citizen innovation, which range from the trivial to the important. So most of us think about it in terms of the trivial, right? We say, oh, yes, somebody managed to put a supercomputer in an Altoids tin or something like this, right? And here's somebody who fits that model, although it sounds rather convenient, you know, to have the suitcase carry you instead of you carry the suitcase. But much more serious things are going on, and that really makes it worthy of policy attention. I will give you a couple of examples of that. Most of what Pedro and I both talk about in this time is going to be focused on examples that have to do with medical patients. Because, in fact, there's a tremendous amount of innovation, and this kind of patient innovation can really change how we fund and support and run medical care. But here's an example. People with diabetes, type 1 diabetes in this case, that's Dana Lewis on the left there, and her fiancé, Scott Lebrand. Now, she's a software engineer, and she determined that she had to make many calculations manually. What happens when you have diabetes, type 1 in her case, is that you have to do complex things to know how much insulin to give yourself and how to moderate the meals that you eat. You have to correct for your glucose level, you have to correct for your insulin resistance, activity, planned activities, current insulin that you have on board. All of this is very hard to do. And it was astonishing that you have to continuously do it throughout the day and in effect make 300 manual calculations. Now, what she wanted was what's called an artificial pancreas, which is not available yet. And when you ask the producers about it, they say what they've said for 15 years now, oh, in 5 years we'll have it. But if you're somebody with diabetes, you want it now. And because of the capabilities that people in the household sector have, after all of us with our technical skills go home at night and become consumers. So every skill that is available to companies is available also to the consumer innovation paradigm. So what happened? What happened is she wanted to make an artificial pancreas for herself. What does it do? Well, on the left there you see it measures blood glucose. And there are continuous blood glucose monitors. You've seen all these advertisements where you make a stick in your thing and a blood level and you do something. Well, now what they have is a little electrode that goes under your skin that continuously measures your blood glucose. Then they have insulin pumps. So normally when you do manual calculations as a result of what the glucose monitor tells you, you then go and you next take a calculation and then you press a button on the insulin pump to inject to yourself enough insulin to go through the day or through the hour. What's needed is an insulin dosage calculator in the middle. This is what she and her colleagues developed. They had a careful understanding of sort of the algorithms that you use depending upon your activities and all the rest of it. And that's what they built. Predictive software that provides real-time treatment recommendations. Then they built a closed-loop artificial pancreas to automatically adjust insulin levels on her insulin pump. She's part of a community called Night Scout. Other people do it too. Notice, this is entirely ahead of the industry that's supposed to serve them. And it's highly sophisticated. And it works. In her case, she also tracks her glucose levels when she keeps them within range. And remember, she's quite good at this. Manually, she could only keep it in range within 50% or so of the time. With the automatic system, she can do it now 80% of the time. And her fear is overcome, because one of the big fears that people with type 1 diabetes have is, and it was her nightmare, is that you go to bed at night, you miscalculate, and what happens is you have orange juice on your bedside table, but if you wake up and you are too low and heading towards a coma, your muscles don't work anymore. You see the juice, but you can't reach it. And they have a purple candle kind of a thing that they post on the web for people who die all the time from this problem. So she's fixing this problem. Now notice, it's legal. The FDA and all these systems deal with companies. Individuals have enormous freedom to innovate. So what we're talking about is a grassroots system here that has tremendous freedom relative to the regulatory bureaucracy that surrounds firms. Big advantage. Now, why is citizen innovation viable without anybody paying to adopt the innovations? It's because citizens are motivated by rewards they give to themselves. Notice the red in the citizen innovation paradigm, self-rewarded, peer-to-peer free diffusion, as opposed to the profit-seeking system of the producer innovators. What kind of motives do they have? My colleagues and I, especially Jeroen de Jong, who's here, have measured this, and what we find is that when you ask citizen innovators in these national surveys why they did what they did, there's a very small fraction that has something to do with selling it, making money. That's the red line in the middle, the black line in the middle. It's 50% personal use, like Dana. It's helping others, 12%. It's having fun and learning from developing it, together 30-something%. So in other words, when you're doing this, this is not typically suffering. You're not saying, oh darn, I have to go to the basement again and struggle with being creative and having fun. No. You think this is fabulous and you're off doing it. You're self-rewarding. Now, you can cluster these innovators. And when you do a cluster analysis of these citizen innovators by motives, you can see that they have different kinds of profiles. The blue in the top left there is personal need. Largely, they have personal need. That's Dana. And then you have participators, people who are doing it for fun. They're the ones who build a boat. They're not really needing a boat. Maybe the boat will float, maybe the boat will sink, but never mind, they're having a wonderful time building a boat. That's the participator mode. Then we have helpers. And this is a very interesting kind of a phenomenon, and I'm going to give you an example. This comes from Pedro's contacts, and it's a wonderful example. It's basically Ivan Owen is that person that you see in the top in black and white. Ivan Owen published on the web some designs he had for hands that were for marionettes. He was a marionette, a puppeteer marionette person. And you can see on the lower left there, you can see what his hands looked like. And this was published on the web. And later you'll see what this kid is doing here. This is a kid who has no hands. And all of a sudden, he's got a marionette-like hand. Now, how did that happen? A person named Richard van Aas saw on the web Ivan's models for marionettes. He had just sawn off half his hand in a carpentry accident. He came to Ivan, they worked together, they developed these kind of hands, because basically what's going on is if you cut your hand, you still have your wrist, and so you can use the wrist to sort of drive fingers in some very quick, efficient way. Now, the kind of electronic models of this cost about $20,000. They're pretty hopeless for kids. Kids especially keep growing and so on. They're called myoelectric. As you'll see, this design was very simple. In addition, it was very cheap because you can 3D print the design for the kids. So if you have a 3D printer, the Central Enable community sends you the designs, you modify it to meet the size requirements of the kid in your neighborhood, and you print it for free for $5. Now, this is rather a remarkable situation. This is not about anybody making money. This is about a system, the citizen innovation system, where people design for free, they give it away for free, they're happy to help in this fashion, and it has blown the myoelectric hand for children system out of the system. I mean, what are you going to do if you compare, if you're a mother with a kid with a $20,000 myoelectric arm, and the kid, of course, immediately sticks it in the bathtub or something like this, and furthermore, every birthday needs another one. It's totally impossible. These are $5. It's extraordinary. Okay. Now what I want to tell you about is how the two paradigms interact. I've given you two examples of citizen innovation paradigm at work. Now I want to give you interactions. So what you see there is you see the two paradigms are linked. On the left is innovation support, a small arrow linking them. On the right is innovation designs, which come from the citizen innovation paradigm down to the producer innovation paradigm. So what you see here is Richard Van Aas, the guy who had cut his hand, and he decided to make a company called RoboHand. So he's an example of an entrepreneur who basically said, okay, I'm going to switch from being a citizen innovator, I'm going to be a producer innovator, and I'm going to bring my design down with me, and then I am a manufacturer. That's true. You have lots of startups. In the US, 50%, actually 46% of the startups that last for 5 years and are built on an innovation come from user innovators. So it's a huge, unmeasured phenomenon again. It's a great source of new companies. It's also good for existing companies. So these kind of designs that travel down, all these sports that you like, for example, mountain biking, what happens is that the peers develop and freely reveal innovation designs for mountain biking. Those flow down to biking producers, and the biking producers benefit enormously because basically they don't have to design. It's for free. Because, remember, the users, the citizens, are giving away their innovations, whether to peer-to-peer or they're giving them away to producers. They do not protect their innovations. Now, this producer saving can be huge, and what happens here is something quite remarkable. Basically, the way current government statistics work, the mountain bike only becomes an innovation that economics and the statistics recognize when a producer makes it. So it's invisible that the user has done all this. It's only when it flows down and the mountain bike starts to be made by the producer does it become an innovation in the statistics, and then it is credited to the producer. The result is that we are vastly overstating the productivity of R&D money expended by producers. In the one area where we studied this, it was in whitewater kayaking because we'd done a 50-year study of that. We found that the innovations that were freely acquired by the producers were worth collectively 3 times more than all the R&D money that the producers had spent over 50 years. In other words, if the producers had had to develop those innovations that they got for free, in addition to the ones that they developed for themselves, their budget would have been 3x higher. That means because they get credit for the citizen innovations as well as their own, this means that their productivity is overstated in the statistics by 3x, which means that we continuously go and say, my, that's really marvelous. We have to protect those guys with more patents. The users do not use patents. The citizens do not use patents. So we have here an alternative system of innovation, which is large in scale, large in scope, and in fact can operate without intellectual property. 10 minutes. I have 10 minutes to go. Okay. So now, how else do the citizen and producer innovation paradigms interact? Citizen innovations complement the producer. That means the producer decides, for example, that he will build the mountain bike because there are economies of scale, and so I nowadays would buy a mountain bike rather than build one, even though the design is perfectly free. But what good is a mountain bike without riding techniques? It's a necessary complement to the bike. The bikes are very specialized. Who's going to use them? People who know how to do mountain biking. All of this essential complement, diffuses peer-to-peer. Users help each other. They teach each other. None of you, I'm sure, went to mountain biking academy. You learn from others. Well, companies are not aware of this, but this essential complement gives the value to mountain bikes that they have. So they're benefiting enormously from this, and yet this other way. Now, citizen innovation is also not so great for companies, in the sense that citizen innovations compete with producer products. The fact that there is a citizen design available, or in the case of a software, a design that is equivalent to the product, means that the amount you can charge for the commercial version is somewhat suppressed. So it's an advantage in that sense to society to have more competition from the citizen innovation paradigm for producers. Finally, we find, and this is going to refer to this final arrow there, the red one, where in fact innovation support is supplied by the producers to the citizens because the citizen innovation designs are so valuable to the corporations. How does that work? It works, we've done some modeling of it. Their profits actually go up. It turns out that when there's a very small number of citizen innovators, it's not worth helping them much. There's not enough. That's on the left-hand side. But when the innovators increase in scale, you start to get higher profits because you're picking up, by giving them tools, you're picking up more useful innovations. Then it declines again as more and more customers who can innovate can also self-supply. So what we saw in the case of the Enable community there was that they had driven the producers to the far side there. They had basically said, you know, what we have got here is so marvelous, we're mostly self-supplying. We're not anymore buying from you. Anyway, here's an example for any of you. I'm sure you're all secret game players. What the company does is it makes games, and this one is called something called Skyrim. It goes out through the market platform. That's the game a producer sells. Then what they give to users is a workshop. They say, hey users, if you want to create modifications, that's fabulous. Go ahead and do it. We'll give you a workshop to do it. We'll give you a workshop to hand it out free. It's going to be fabulous. And by the way, you can't charge anything for it, so that all the extra value that the game gains because of your modifications flows to us, the producer. Thank you very much. That's the way the system works. Now, how do citizen innovations get diffused that are not of interest to producers? Who has an incentive to diffuse free stuff? Now, I mentioned to you that producers have in their system, the producer innovation system, they have a market failure. Namely, you have spillovers which allow other people to benefit, and that's why we have patents and so forth. There are also market failures that have to be addressed in the case of the citizen innovation paradigm. Citizens, as I mentioned, seldom protect their innovations. They don't apply for RPRs. So what happens then? Who has an incentive to diffuse free stuff? Well, it turns out that the market failures in the citizen innovation paradigm that can be addressed with policy, and Pedro will talk a bit about that, is that if I'm a citizen innovator and I build myself a bicycle or I build myself an artificial pancreas, I'm building it for me. I don't have any incentive to build it for you as well because you're not paying me at all. It's an externality. In the same way, I'm building it for me in an economical way because I can only afford to build it with respect to my benefit. Your benefit, even though there are thousands of other people who could use an artificial pancreas, is something I just can't afford to serve. And finally, citizen innovators may not spend enough in diffusing information because, again, this costs them private money, and because there's a lack of a market connection, the private money cannot be returned by the beneficiaries in the form of some sort of price. Now, we could say, let's create a market by, let's do the equivalent of carbon offsets and so on, carbon markets, markets for carbon. Let's internalize the externality. But in fact, the advantages of open and free innovation are so strong, instead, what we should do is something else. What this shows here, it's familiar to all of you, I'm sure, from Economics 1, is that there's a deadweight loss associated with patents. Namely, they can put a monopoly price on the product that they sell, which excludes people who cannot afford that from having the opportunity. Those are all the people in pink there. They can't quite pay the price that the producer sets. A lot of it is profit, as it is because of monopoly pricing allowed by the patent. So these guys suffer. It's a deadweight loss. Again, the only reason that we do patents, it's a devil's bargain, is because we thought there was no alternative. Now, when you look at the scale of citizen innovation, the fact that it's getting stronger and stronger because design is getting cheaper, communication is getting cheaper, sophistication is getting higher, there is an alternative that's growing, and I think here in the EU we should think about supporting this in some intelligent ways. Now, we can learn to mobilize helping motives, for example, to enhance the operation of the citizen innovation paradigm. That's the enable thing. In our business schools today, we only teach about the robo-hand option. It's like, oh, you can come and you can start a company based upon this innovation. But the fact that you can have these systems, that free innovation is freely diffused and people support it, is a new sort of social innovation system that really has to be explored and developed. So now I go to my colleague who will tell us about this wonderful example. And so... Do you want this thing?
Maybe I can use this one.
Okay.
Yeah. Or I can use that. It's on. Can you hear me well? Now it is. So first of all, thank you so much for the opportunity to tell you about Patient Innovation, a platform that we built 16 months ago and that is aimed at collecting and facilitating the sharing of solutions developed by patients, caregivers, collaborators. Let me tell you a little bit about our project. As I said, we decided to do this 16 months ago to facilitate the sharing of solutions developed by patients, caregivers, and I'm talking about non-professional caregivers and collaborators. This is open to all diseases, this is open to all geographies and to all languages. And what happened in the past 16 months is that we collected 300 innovations that were collected by the platform and were curated by our medical team. In fact, the number of submissions is much higher, but because the innovations have to be screened by a medical team, the number is 300. But let me repeat this. So, out of a research project in Lisbon, Portugal, in 16 months, we identified 300 medical innovations that were all resulted from citizen innovations, from user innovations, as Eric was describing. This is the rate of growth in the past 16 months. We have solutions from 30 countries. The top contributors are the US in first place, Portugal second, where the project is based, England, Australia, Brazil, Israel, and a bunch of other countries. And why do we think this is really relevant? Because, I mean, this all started because we are researchers. One of the studies that we did, looking at the community of rare disease patients, showed us that, in fact, about 8% of rare disease patients have developed something new, not just new to them, but new to the world. In fact, a much higher percentage develop something new to them. But when our medical team looked at the solutions, they said, wow, this is not just new to them. In 8% of the cases, it's new to the world as well. And if you think about a percentage like this being true for the patients in total, in general, around the world, you can just see the potential of this. The second important finding is that this was having a real impact on their quality of life. When we compare the quality of life before the innovation and after the innovation, we could see that on average, both the quality of life of the patient, but also the caregiver, and I'm talking about non-professional caregiver, the father or the daughter of a patient, was also improving significantly. On average, the improvement was 2 for patients and 1.9 for caregivers. So these are very good news. First, there's a lot of innovation out there. This innovation really matters for them. It increases the quality of life. What is the bad news here, and why did we start the project? Well, because these innovations rarely diffuse widely. At most, these people will say to other patients, to local friends, that they did something that works for them. They very rarely say this to medical professionals. In fact, only 5% share the news with their doctors. Many of them are really afraid, in fact, of doing that. So, 3 findings, right? These people innovate, these innovations are important for them, but they don't go anywhere. So, we are dealing here with some market failures, as Eric just described. First, these people, users, typically try to fix their own problem. The effort that they do to develop the solution is limited. As soon as they finish their solution, they stop there. Well, what we know is that a platform like ours is really a place for different sorts of collaborators, from engineering students to 3D printing enthusiasts, to jump in and help develop the solutions that were first designed by patients. Let me give you an example. Let me tell you about Mr. Tail Goldsworthy. You know, in 2002, Tail went to see his doctor, and his doctor told him, "I'm afraid you are going to die." And if we think about this, this is really bad news, right? Oh, well, of course. But if you think from a need perspective, if the need is the mother of invention, one knowing that one is going to die is a strong incentive to do something about it. And Tail went home thinking about his own problem. He was able to get a lot of medical records from the doctor, and he started thinking about his own problem, because he's an engineer by training. And he thought, from an engineering point of view, what he told me is ridiculous. He was going to die because he's a Marfan syndrome patient, he's a very big man, and his aorta is very fragile for the amount of blood that flows through his aorta. So the problem is that it could have a rupture at any moment that the doctors could not really stop. He thought, you know, if I develop some sort of aortic support to put around it, maybe I can save my life. And he did that. You know, a couple of months later, he walked back to the doctor's office with this thing that you see over there, saying, "Look, I did this for myself, maybe with your help," because this is something you cannot do alone at home. Of course, I don't recommend this at home. "But maybe I can save my own life." And he convinced the doctors in England, right? I'm not talking about any weird medical system. He did this in England. He saved his own life, and he saved the life of 56 other patients that have received already the same medical support. So, again, this was 11 years ago. He saved the life of 56 other people already. He couldn't do this alone. This requires a lot of further development. That was one of the problems that Eric already identified. What's the second market failure? Well, diffusion. These people fix their own problems, but they don't care much about trying to solve other problems. They don't even know how to do it. So one of the things that we already do in our platform, and I think we do very well, is to facilitate the free sharing, as Eric was talking about. This is something that we do, and let me give you an example of a solution that is so simple that as soon as I share the solution, you know how to replicate it. Joaquina Teixeira is a Portuguese mother of a kid with Angelman syndrome. Her son, among other complications, one of the problems that this kid has is that when the kid is supposed to stand up and walk, They basically don't have the muscles to do that. They don't have the motivation. His mother tried all sorts of things to try to convince him to stand up and walk. Nothing seemed to work. One day she was really surprised because she went to a party and she took the kid. And when the kid saw some colorful helium balloons floating around, he started jumping to get the balloons. And she was like, really? Finally, I see you excited with something. So the next thing she did was to buy 100 balloons. She spread the balloons around the house, and shortly after, the kid was walking. So you see, it was really surprising for us, because in conferences like this, we were talking about this solution, and suddenly parents were coming to us and saying, thanks for sharing. You know, this works for my son as well, even in cases in which the disease was very different. We actually had the mother saying to us, thanks for sharing. I think my kid is just lazy, but it works too. So, you know, it's amazing because some of the solutions are very easy to share. But others are not so easy. And in fact, it's in the benefit of everyone that these solutions are further developed and then commercialized. So now I'm talking about the second line that we are developing now, which is helping patients like Kelly's or Kelly's father, who developed this for her daughter that had to do a lot of chemotherapy. And, you know, it's a very cute solution, and just looking at the picture is probably not going to help you much. You know, if we help these patients bringing this to the market, this is going to help a lot of other patients. And that's what we are talking about now, helping patients like Debbie out of Israel. Debbie, in fact, has probably developed over 10 innovative solutions that were all medically validated. Debbie has has a son with cerebral palsy, one of the problems in that these kids don't walk. Now she developed this UpSys system that you see over there, and suddenly the kid is walking, and this is being commercialized already. So what we are doing now is to develop this health innovation accelerator that is aimed at helping patients and caregivers, non-professional caregivers, to develop their solutions and bring them to market. To be honest, our dream is to have an ecosystem of startups that are created or co-created, because often these patients don't know how to do it, by themselves, by the patients, by the caregivers, and by the collaborators. We think this, in fact, can really contribute to more effective medical care at a very low cost, because one of the things that we know about user innovations is that they work. Right? They were developed by users that had the need. They fixed the problem, and they typically work with very low development costs. So let me tell you some of the things that have happened in these 16 months, which we are very surprised but proud at the same time. We've got support from patient associations literally from everywhere, from Australia to Malaysia to Brazil to the UK to the US. And this was super important because patients liked the idea. Then we were surprised with the support of entities like the United Nations Development Programme that put on their website that we are very excited about this project and invited us to go to New York to present this. The project was semi-finalist in a competition at Harvard University organized by Harvard Medical School and Business School. And we were the only non-US semi-finalist in this competition that had 475 submissions from everywhere. But more than that, we were #1 in many dimensions, including the votes from the crowd. And not just that, in fact, let me just share that we had 5 times more votes than the second project that got more votes. You know, the digital initiative called us a startup to follow, which is interesting because we are not even a startup, but we will be. And just recently someone was saying, look, Virgin Airlines has an article on their plane saying that patient innovation is an impressive platform. How did you do this? And I have no idea. This is something that we didn't do because we don't have a budget for marketing. So basically, I've been sharing with you an implementation of a user innovation platform. How can we take the concept and make it work? Well, this is an experiment that was not supposed to happen. It was just a research experiment started 16 months ago and is now having a very significant impact, we think. According to one of our advisory board members, Sir Richard Roberts, a Nobel laureate, we have actually several Nobel laureates in our advisory board, people that approached us and made themselves available to help. This is an outstanding use of social media that should help many disadvantaged people. And we think he's right. Thank you so much.
Can you hear me? You can hear me through that one. Is that, well, there we are. It's working. We do have just a few, thank you so much, really inspirational stories about what citizen innovation can do. Fascinating, that relationship between citizen innovation and producers. I had one question, if nobody else does, which is, are there any implications for policymakers? Do they have a role in creating this sort of virtuous circle? There's obviously a driver for companies, the savings they're making on their development budgets, but is there anything policymakers need to do? But before I bring you up to answer that, any other questions for either for Eric or for Pedro? Eric, can you just, or indeed Pedro, just in terms of how policymakers, is it in, I'm thinking of the diffusion question as well. Pedro, come up and join us. Do you see a role here in this relationship between the two to accelerate, in your accelerator model, is there a role for policymakers?
I think there's an enormous role. I mean, in a sense, otherwise you would not be interested. When you think about the entire infrastructure around intellectual property, this huge infrastructure, the subsidies and the rest of it, to address the producer innovation market failure, we have shown that citizen innovation actually improves social welfare. It also has market failures with respect to incentives to diffuse and so on. It needs creative, innovative models of policy that can drive it forward. Some of these are happening by happenstance. What you do is you lower the cost, for example, of citizen innovation by having maker spaces. You've probably heard of these. You have sites where you can cheaply download your innovations. You need standards so that one person can read the digital file for another person's innovation and so on. All the sorts of things that we have done for the internet are also required for citizen innovation. There's a tremendous amount to do, and I think that's exciting for people in the EU who are policymakers. Aren't you bored with doing patent-related stuff after all these years?
Pedro, a thought from you on how the policymakers can really help.
So I think, yes, they can really help, because as Eric was describing, the entire system is set up for producers. When we talk with these patients, we see that many of them, many of these heroes that were actually able to do something about their innovations, faced a lot of resistance, all sorts of resistance from people that didn't believe in their innovations, all sorts of resistance from people that, of course, were not available to fund their innovations, because, you know, the entire system is prepared to fund producer innovations, and this is very clear, for instance, in the European Commission calls. While if we don't fit in your categories, you will say, I'm sorry, you don't fit, right? So, but we try to claim, oh, this is really important, it seems to us, but then it doesn't fit. Yes, from intellectual property protection to funding, there's a variety of...
Add measurement too.
And measurement, because of course nobody knows that this exists. It's not in the official statistics. So how can managers manage something that they don't quantify, right?
Absolutely.
So it makes sense that we don't make good decisions about stuff that we don't measure.
Yeah, so where we really could use some help is, you know, the social surveys that you do now should include citizen innovation. Right now, these time of use studies and so on are biased against user innovation. If somebody says to you as a data collector on what are you doing with your time, Mr. Citizen, he says, I'm creating a new vehicle. What they say is, code as fixing his car. Right? We could fix this stuff. It's just that we have so many assumptions that it's all about producer innovation that we're not picking up user innovation, and we should.
Last question. Oh, there is one there? Yes, please. And please introduce yourself so they know who you are.
Thank you. Thomas Arnold from DG Research and Innovation. Fantastic talk, trying to relate this to the #1 priority of the Juncker Commission. Is it possible to quantify how much jobs and growth are induced through citizens' innovation?
Not yet.
But it will be.
Are you about ready to fund us for that? No, I mean, I really want everybody to join us if you can, because we have 200 people working on the entire panoply. The low-hanging fruit academically is enormous. That is one example. 10,000 people are working on the existing producer paradigm. So, fabulous idea, yes.
I mean, not to mention the huge potential for, in this case, patients that want to become entrepreneurs to develop what they did and, you know, get these solutions to the market, right? Many of these 300 solutions, in fact, are now being developed in one way or another by the patients, sometimes and quite often with help of other collaborators, engineering schools, 3D enthusiasts, people of different types.
Thank you so much. Very last, and one sentence. We've been talking a lot today about memories and dreams. So a memory of past glories in Europe in terms of innovation and so on, and a plea that we want to talk more about our dreams for the future. If you had, and I've been doing this to people all day, so I wanted to do it for you, in a sentence, one priority, one thing that you think needs to be done to realise all of this enormous potential, what for each of you, you have the mic, so Pedro, you go first. What for you is your one thing above all else we need to do to capitalise on this?
So what I want to do, my dream, is to create an ecosystem of companies that are founded or co-founded by patients, non-professional caregivers, or other collaborators. We need your help to make this happen, right? Maybe in your policies you can actually accommodate some of the calls to include user innovation, or as Eric called today, citizen innovation.
Thank you. Eric, you have the last word.
Empower citizens. I mean, basically at the moment, what the economic and innovation systems do is they are biased against citizen innovation. For instance, patents are not used by citizens, they are used by producers, often against citizens. What we have to do is at least create a level playing field, and when we do, we'll all be better off.
Thank you. I'd love to keep you here all afternoon, but I know you have a plane to catch, but I think the Commissioner would like to say something by way of closing this session.
No, I just wanted to thank you, Eric and Pedro. I think it was really an inspiring session for all of us and for the ones that are doing the policies. And it actually opens our mind to something that is quite new in Europe, and that I hope, as a politician, to actually to put in my vision. And that's your inspiration, Eric, from reading your book, that actually get me to the inspiration of the open science, open innovation, and open world, because that's what citizens do. So thank you so much. It was a great privilege. I just wanted to have a word before you go.
Thank you, Commissioner, and thank you, Eric. Thank you, Pedro, for such wonderful inspiration.